Welcome back. In this video, we are going to solve a structural design problem that involves an isolated footing design using LRFD method based on eStructural Design Zen found on the App Store. Design an isolated rectangular footing using load and resistance factor design for a 250 mm by 250 mm square column carrying an axial dead load of 100 kN and axial live load of 30 kN. Design criteria as follows: strength of concrete 21 MPa, main bars 12 mm bar grade 276, soil bearing capacity 120 kPa, approximate dimension ratio of 1:2. The footing carries an axial dead load of 100 kN and axial live load of 30 kN for a factored load of 168 kN. Enumerate input parameters required. Footing name F3, shape of footing, rectangle, depth from natural grade line 1200 mm, long direction bars 12 mm bar at grade 276, short direction bars 12 mm bar at grade 276, strength of concrete 21 MPa, soil bearing capacity 120 kPa, column 250 mm by 250 mm, and factored axial load 168 kN. Given allowable soil pressure equals 120 kPa, depth from natural grade line equals 1200 mm, and assumed footing depth equals 205 mm. The effective soil pressure is 99.16 kPa. Given axial dead load equals 100 kN and axial live load equals 30 kN, the footing width is 0.81 meter and footing length is 1.62 meters. The ultimate soil pressure is 128.029 kPa. Critical section diagrams for punching shear, beam shears, and moment evaluations. At long direction, given ultimate soil pressure equals 128.029 kPa, footing width equals 0.81 meter, footing length equals 1.62 meters, and column side equals 250 mm, the maximum moment is 24.33 kN meter. Given resistance factor equals 0.9, B equals 810 mm, and D equals 124 mm, the beam design ratio Rn equals 2.171 MPa, and reinforcement ratio Rho equals 0.00841. Continue at long direction. Given Rho equals 0.00841, B equals 810 mm, and D equals 124 mm, the area of steel for long direction bars is 844.7 square millimeters, and the number of bars for 12 mm bar is 8. At short direction, given ultimate soil pressure equals 128.029 kPa, footing width equals 0.81 meter, footing length equals 1.62 meters, and column side equals 250 mm, the maximum moment is 8.13 kN meter. Given resistance factor equals 0.9, L equals 1620 mm, and D equals 124 mm, the beam design ratio Rn equals 0.363 MPa, and reinforcement ratio Rho equals 0.00133. Use Rho minimum of 0.00507. Continue at short direction. Given Rho equals 0.00507, L equals 1620 mm, and D equals 124 mm, the area of steel for short direction bars is 1018.46 square millimeters. The area of steel at center strip is 678.97 square millimeters, and the number of bars for 12 millimeter bar is 7. The area of steel at outer strip is 169.75 square millimeters, and the number of bars for 12 millimeter bar is 2 on each side. The factored beam shear force at long direction is 58.178 kN. The nominal force is 77.571 kN, less than 78.247 kN concrete capacity. The factored beam shear force at short direction is 32.355 kN. The nominal force is 43.14 kN, less than 156.493 kN concrete capacity. The factored punching shear force is 150.091 kN. The nominal force is 200.121 kN, less than 280.528 kN concrete capacity. Design recommendation as follows. Fc prime equals 21 megapascal, Fy equals 276 megapascal, Qa equals 120 kilopascal. Footing size is 810 mm by 1620 mm by 205 mm. Depth of footing from natural grade line 1200 mm. Long direction bars of grade 276, 8 pieces 12 mm bar at 94 mm on center. Short direction bars of grade 276, center strip bars 810 mm wide, 7 pieces 12 mm bar at 110 mm on center. Outer strip bars 405 mm wide each side, 2 pieces 12 mm bar at 203 mm on center each side. Thank you for watching. If you learned something from this video, please like, share, and subscribe to this channel.